Assalamu alaikum, dear student. This is Muhammad Mahbub, lecturer in chemistry, English medium day shift, Rajagutara Model College. Today, I would like to deliver a very important lecture on organic chemistry. This is my fourth lecture of the chapter. Today, I would like to deliver a very important speech on some topics of this chapter. For the first time, I would like to say something about haloform reaction. Okay, what is haloform reaction? Reaction in which halogen react with organic compound that contain methyl keto group in presence of strong base to produce haloform is called haloform reaction. Basically, this is the reaction to produce haloform. Okay, so the reaction where halogen should react with such type of organic compound. Which type of organic compound contain methyl keto group CH3CO in presence of strong base, for example sodium hydroxide or potassium hydroxide, to produce haloform, a salt of acid, sodium halide and water. This is haloform. The general form of haloform is CHX3. You know, there are different types of haloform is possible, for example chloroform, bromoform, iodoform. This type of haloform is possible. Okay, so X is basically here chlorine, bromine, iodine, something like this. Okay, especially halogen. Okay, so the point that you must have to note it in that case, which type of compound should participate haloform reaction. So this compound must contain methyl keto group. Okay, we know very well methyl keto group, normally aldehyde and ketone contain methyl keto group. Okay, so the compound that should participate in haloform reaction should have general formula like this: CH3CO is a must, methyl keto group containing. If air can attest, if this valency can be filled up by hydrogen, then this compound will be aldehyde. If this valence is filled up by a alkyl group, then it will be a ketone. So normally you can say that methyl keto group containing aldehyde or ketone can participate haloform reaction. Now this is another important point. There are some alcohol that can also exhibit, that can also show haloform reaction, but this type of alcohol must contain CH3CHOH. In case of alcohol, to show haloform reaction, the main point is this type of alcohol must contain CH3CHOH. Now the question, why this type of alcohol show haloform reaction? Because you know very well, during the time of haloform reaction you have to use a haloform, you have to use a halogen. You know very well chlorine, bromine. Normally halogen can act as oxidizing agent, right? So as halogen can act as oxidizing agent, if you use this type of alcohol, CH3CHOH containing alcohol, if you use, then CHOH, the portion CHOH will be oxidized by halogen, this halogen. Okay, by this way this CHOH portion will be converted to CO, then CH3CHOH group will be converted to CH3CO. By this way you will be able to get here methyl keto group, and that's why the alcohol that contains CH3CHOH group can also participate in haloform reaction. So these are the compounds that can participate in haloform reaction because all the compound contain methyl keto group. Okay, just you consider this example. If you consider this example, then you will get this compound contain CH3CO group, methyl keto groups. At the same time, this compound also contains CH3CO group. This compound also contains CH3CO group. Okay, so all of them can participate in haloform reaction. Now just you consider these three alcohol. Both of the alcohol, all the alcohol contain CH3CHOH group. This compound contains CH3CHOH group. This is CH3CHOH group. So this compound also contains CH3CHOH group. At the same time, this is also possible in this alcohol. So all the alcohol also participate in haloform reaction. If you consider the example of this compound also contains CH3CO group, though it contains a phenyl group. So all the example that I have written on the board can have the capability to show haloform reaction or participate in haloform reaction. So dear student, now preparation of chloroform. By using haloform reaction you can easily prepare chloroform. If you want to prepare chloroform, you have to use here ethanol. From ethanol you can easily, by using haloform reaction, you can easily prepare chloroform. Okay, this reaction is basically involved with 3 steps. First one is oxidation, second one is substitution, and third one is hydrolysis. Okay, you know very well, during the time of chloroform reaction or haloform reaction, you have to use a chlorine atom, right? Halogen molecule you must have to atom. Each and every halogen can act as a oxidizing agent. You know it very well. Okay, so as it is alcohol and this is the oxidizing agent, as chlorine can act as the oxidizing agent, so it can oxidize this alcohol. As it can oxidize this alcohol, after the oxidation this alcohol will be converted to aldehyde. We know very well, when you oxidized alcohol it will be converted to aldehyde. If you further oxidized alcohol, later it will convert it to acid. Okay, so by using this oxidizing agent chlorine, ethanol can be oxidized, and by this way ethanol will be converted to ethanol. This is the first step. In second step, there happen basically substitution reaction. All the hydrogen atom of this ethanol molecule will be substituted by chlorine atom. Okay, here by this way they are produced Cl3CHO trichloroethanol, which one is called, and also this one is called chloral. Okay, and in that case they are also produced HCl in that case. So the point that must you have to remember in that case, when you oxidized ethanol, this is converted to aldehyde, which aldehyde contain methyl keto group. So there has no problem to carry out in right now haloform reaction. Okay, haloform reaction must contain methyl keto group, you know, so you have already got it. Now the third step is basically hydrolyzed reaction. When you hydrolyze this chloral molecule trichloroethanol, which one is called, when you hydrolyze it by using a sodium hydroxide, then this compound will be converted to chloroform CHCl3, and in addition with a salt of acid, right? Okay, salt, sodium methanoate, right? Okay, after that, as they are produced HCl, there is you have used already sodium hydroxide, strong sodium hydroxide as alkali we have already used here, so there must happen a reaction in between HCl and sodium hydroxide. By this way they are produced sodium chloride and water. Finally the total reaction is reaction of ethanol with chlorine in presence of a strong base sodium hydroxide, and by this way they are produced chloroform CaCl3 and salt of acid, sodium methanoate, sodium chloride and water. So our target product is CHCl3. So by using this chloroform process or haloform reaction, we can easily prepare chloroform by maintaining 3-step oxidation, substitution and hydrolysis. So dear student, now purification of chloroform. Chloroform can be used as anesthetic. Okay, you know. Again, chloroform has the chance to be oxidized with the air oxygen. This is very important point and you have to note it. Okay, chloroform has the chance to oxidize in presence of oxygen. When it just come to the contact of air, it will be oxidized, and by this way it will produce phosgene gas in addition with HCl. Okay, so if you have a chloroform, either it is oxidized, is there presence any phosgene gas or not, and that's why you have to make sure the test. Okay, so if you take any sample of chloroform, if it is oxidized, if there presence any phosgene gas or HCl gas, if you add here 1 to 2 drops of silver nitrate, in that case this HCl that is produced by the oxidation of this chloroform, this HCl will react with silver nitrate and they produced a white precipitation of silver chloride, and from this white precipitation of silver chloride, you will be sure of that these chloroform must be oxidized with the air contact. Okay, so from this concept you will be sure of that this chloroform either it is pure or impure. Okay, so this is very important reaction. At the same time, phosgene gas is very toxic gas. Phosgene gas is very toxic gas. If chloroform is in oxidized state, there must presence phosgene gas. The presence of phosgene gas, it will really, so as it is toxic, so it is so harmful to you all. Now I would like to say something about the identification test of amine, chloroform. If you want to identify chloroform, you have to add here aniline, which one is aromatic amine, at the same time alkali. Okay, at 70 degrees Celsius temperature there happen a reaction, and by this way they produce a carbylamine. This one is called carbylamine, and this one also called aromatic isocyanate. Okay, isocyanate compound. So when you make sure this reaction, there will produce a very awkward smell. Okay, if this carbylamine compound is produced here, they are produce a very awkward sound, a very awkward smell. From this smell, then you will be able to understand that there must presence chloroform. At the same time, this is also the reaction to identify any aromatic compound, aromatic amine or aliphatic amine. Okay, so this test can be effective both to test chloroform at the same time amine. Now I would like to say something about the uses of chloroform. Chloroform can be used widely in our day-to-day life. Widely, it can be used in industry, it can be used in medicine industry, different types of it has lot of application. Okay, it can be used industrially as an important solvent. It can be used as an important solvent of wax, fats, rubber, etc. Okay, at the same time it can used as an anesthetic. I have already told it for a number of times. It can also used in preparing chloropicrin and chloreton. Chloropicrin and chloreton, they have a lot of importance in industrially, so this can also produce. Okay, finally it can be used in medicine industry. It has a lot of demand, so this is very important. So in this slide we are able to know about the purification of chloroform, about the identification of chloroform and uses of chloroform. So dear student, now about aldol condensation reaction. This is very important reaction. This is basically a reaction of aldehyde or ketone to produce aldol. Now the question is, what is aldol? Aldol is basically beta hydroxy aldehyde or beta hydroxy ketone. Beta hydroxy aldehyde or beta hydroxy ketone is called basically aldol. So aldehyde or ketone that must contain alpha hydrogen, that can undergo self condensation to produce beta hydroxyaldehyde or ketone, which one is called aldol condensation reaction. So this is basically the reaction in between two aldehyde or two ketone, or in one aldehyde or one ketone, that must contain alpha hydrogen. Now the question is, what is alpha hydrogen? Alpha hydrogen that is attached with the adjacent carbon of the carbonyl group is called alpha hydrogen. For example, this is the carbonyl group, right? This is the carbonyl group, and this is the carbon that is attached with the carbonyl group. This is basically the adjacent carbon, right? So the hydrogen that is attached with the adjacent carbon, so this carbon is basically the adjacent carbon to the carbonyl group. So I can say this hydrogen is basically called the alpha hydrogen. So the hydrogen that is just attached with the adjacent carbon of the carbonyl group, this hydrogen is called alpha hydrogen. So here this hydrogen is alpha hydrogen, this hydrogen is also alpha hydrogen. So the reaction in between two aldehyde or two ketone, or one aldehyde or one ketone, that must contain alpha hydrogen, they can undergo self condensation in presence of a diluted base to produce beta hydroxy aldehyde or beta hydroxy ketone, which one is called aldol, is called aldol condensation reaction. Here this is functional group, you know. So this carbon is called alpha carbon, This carbon is called beta carbon and this carbon is called gamma carbon. So beta hydroxy, this is basically the product. Okay, you have already seen this is aldehyde, this aldehyde. There are two aldehyde have taken here. Both of the aldehyde contain alpha hydrogen. This aldehyde contain alpha hydrogen, this aldehyde contain also alpha hydrogen. Okay, when this reaction is carried out, this reaction must be carried out in presence of a diluted base and they have produced this product. What is this product? This product is basically, you have seen, beta hydroxy. Okay, this is alpha carbon, this is beta carbon, this is gamma carbon, and beta carbon contain a which hydroxy group. So this, the name of this compound is beta hydroxy aldehyde. It can be beta hydroxy ketone also. If you take both of them are ketone, then the product will be beta hydroxy ketone. If you take one aldehyde and one ketone, in that case the product will be beta hydroxy aldehyde. So the product will be beta hydroxy aldehyde. Product can be beta hydroxy ketone. Product can be beta hydroxy aldehyde also. Okay, so the beta hydroxy aldehyde or the beta hydroxy ketone is called aldol. Okay, this type of product, if produced in any reaction, this type of reaction is called aldol condensation reaction. So right now I would like to say something about the mechanism of this reaction. This is basically the mechanism of this reaction. For the first time, diluted base will attack this alpha hydrogen. You have already seen this is basically the alpha hydrogen. This diluted hydroxyl ion will attack, nucleophile will attack this carbon, this hydrogen atom, alpha hydrogen atom. Here they will produce water and this portion will be converted to carbonyl. You have already seen. And this carbonyl will attack the another carbonyl group of the aldehyde. As oxygen is electronegative, then the oxygen will shift the bonded electron towards itself. By this way oxygen become partially negative in charge and this carbon will be partially positive in charge. So as it is positive, so nucleophile as a carbonyl, as a nucleophile will attack to this carbon. Okay, by this way they produce this product. After the formation of this product, as this oxygen is negative in charge, so from water it will receive a proton, right? When it will receive a proton, then you will get the product beta hydroxy aldehyde, which one is called aldol, which one is my target product. So the reaction where two aldehyde or two ketone or one aldehyde or one ketone must react each with other in that must contain alpha hydrogen in presence of a diluted alkali to produce aldol, beta hydroxy ketone or beta hydroxy aldehyde. This type of reaction is called aldol condensation reaction. Okay, so dear student, now about Cannizzaro reaction. This is very important reaction, Cannizzaro reaction. So this is reaction that can be happen in between two aldehyde, where these two aldehyde must not contain any alpha hydrogen atom. So the reaction in between two aldehyde that must not contain any alpha hydrogen, in presence of strong alkali, they can undergo self-oxidation and reduction reaction to produce one acid or salt of acid and alcohol. This type of reaction is called Cannizzaro reaction. Okay, again say the reaction between two aldehyde that must not contain any alpha hydrogen in presence of strong alkali, for example potassium hydroxide, sodium hydroxide, they can undergo self-oxidation and reduction. One of the aldehyde will be oxidized and these oxidized will be converted to acid or salt of acid, and another aldehyde will be reduced to alcohol. So the process, by this way they are produced a salt of acid or acid and alcohol. This type of reaction is called Cannizzaro reaction. Okay, look at the picture please. Look at the reaction. You have already seen in the board there are two aldehyde have been taken here. This is aldehyde, both of them are methanol or formaldehyde. You must have to notice clearly that both of them does not contain any alpha hydrogen, right? Both of them does not contain any alpha hydrogen. So this type of reaction is basically undergo or participate in Cannizzaro reaction. So both of them does not contain any alpha hydrogen atom. One of the aldehyde get become oxidized, right? And another aldehyde get become reduced. There must happen oxidation and reduction reaction. I have already mentioned it. So as there happen oxidation and reduction reaction, so one of the aldehyde will be oxidized. You know very well, if any aldehyde, if it become oxidized, it will be converted to acid, right? When you oxidized any aldehyde, it will be converted to acid. At the same time, another aldehyde here get become reduced. If you reduced any aldehyde, it will be converted to alcohol. I hope you know it. So the aldehyde, which one is oxidized here, it is converted to acid, or as their presence for potassium hydroxide, so they are produced salt of acid. And the aldehyde that is reduced here, it will be converted to aldehyde, alcohol. Okay. So at the same time, in case of benzaldehyde, these are two benzaldehyde, they are also aldehyde, and they doesn't contain any alpha hydrogen. They also undergo this Cannizzaro reaction. In that case, the product will be this and this. One is salt of acid, another is alcohol. Okay. Now I would like to say something about the mechanism of this reaction. Here you must have to use a strong base. 50% potassium hydroxide you have to use, right? Okay, when you use potassium hydroxide, so it should supply here OH hydroxyl ion as a nucleophile, and this nucleophile should attack to this carbon, as this bond is here oxygen as electronegative element is present here, so it should withdraw electron. It should shift electrons. The electron should be shifted towards the oxygen atom. Partially, oxygen atom become negative in charge, and carbon atom will be positive in charge. So this nucleophile will attack to this carbon, and they are produce this product. Okay. After the production of this product, then from this compound, this carbon hydrogen bond will be broken in such a way that as this oxygen bond, the carbon oxygen bond is, this bond is shifted here. Okay, please look at the mechanism clearly. As the oxygen with having 2 electron shift to here, and they produce carbon double bond. Okay, so carbon hydrogen bond will be broken here, and it will be broken in such a way that this hydrogen will be out from here as a H minus, as a hydride, right? It will be out from here as a hydride, not as a proton. It will be out here as a hydride. When it will be out from as a from here as a hydride, then it will attack to this carbon as a nucleophile, right? Then as oxygen is electronegative, so it will pull the electron towards itself, and this carbon will be positive in charge, and this is as a hydride. This is as a hydride will attack to the carbon. Okay, by this way they have produced this product. These will convert it to CH3CO, CH3O, okay, alkoxide, methoxide ion, and this will be converted to acid. Okay, after the formation of this product, this will be as their presence sodium hydroxide, so this hydrogen will be received by this alkoxide, and it will be converted to alcohol. And here as they are produced negative charge, so they are produced this acetate ion, this methanoate ion will be react with sodium plus, and they are produced salt of acid. So this is basically the way. In this way, this is clear to us that they are produced a salt of acid and a alcohol. Oxidation and reduction must happen in this reaction, and there must not present any alpha hydrogen in the aldehyde, which will be react as reactant. So dear student, now manufacture of ethanol by fermentation. Okay, if you want to prepare ethanol by this process, you have to, there are 3 steps you have to follow. Okay, for the first step is collection of starch from starchy material. You can collect starch from starchy material. For example, potatoes, it can be a starchy material. Okay, if you want to collect starch from starchy material, you have to crush these potatoes for the first time. Then these crushed potatoes, you have to heat it. You have to heat these crushed potatoes at 140 to 150 degrees Celsius temperature under pressure. Okay, by this way, we know very well there is a starch in the starchy material. There must have starch in the starchy material. When you maintain this temperature under pressure, the starch from the material comes out and goes into the solution. The solution containing starch. Okay, now the solution that you have got containing starch is called mesh. So what is mesh? Mesh is basically the solution containing starch is called mesh. Okay, now the second step. Okay, second step is hydrolysis of starch to produce maltose. Now I have to convert the starch into maltose. If you want to convert starch into maltose, you have to make sure the reaction in presence of a diastase enzyme. Okay, actually the enzyme diastase can be produced from starch. Okay, when you maintain the temperature 30 to 60 degrees Celsius temperature, then the diastase enzyme will be come out from this starch, and in presence of diastase enzyme there will happen this reaction. This diastase enzyme will convert starch into maltose, which one has the molecular formula C12, H22 and O11. And this is the last step. After you have got maltose, then the last process is fermentation of maltose to produce ethanol. Okay, then when you have got maltose, then you have to add here yeast. Okay, yeast can have the capability to produce, to create, to supply maltase enzyme. When you add here yeast, it should supply maltase at 30 degrees Celsius temperature. Then this maltose will be converted to glucose. After the conversion maltose into glucose, then in presence of yeast it will also supply zymase enzyme, right? So by using this zymase enzyme, this glucose will be converted to ethanol. So by this way you will be able to get ethanol. So for the first time, briefly I would like to say, for the first time you have to convert starch material into starch. You have to find out starch and you have to find out mesh. Okay, after you find out mesh, then this mesh will supply diastase enzyme, which diastase enzyme will convert the starch solution into maltose. And after having maltose, you have to add here yeast. It will supply two enzymes. For the first time it will supply maltase. This maltase will convert this maltose into glucose, and after having glucose, yeast will supply zymase enzyme, and this zymase enzyme will convert glucose into ethanol. By this way you will get ethanol. This is basically the process, which process is called fermentation process. Okay, by this way you will get 7 to 12% ethanol solution. 7 to 12% ethanol solution is called wash. Okay, so after having this wash, you have to make sure the fractional distillation of the wash is then subjected to fractional distillation to get rectified spirit. Okay, so after you have got this ethanol, you have to convert this ethanol into rectified spirit. Finally, after having the rectified spirit, you will be able to get absolute ethanol solution. So dear student, after the lecture you will be able to know about haloform reaction details. You will be able to know about chloroform details, aldol condensation reaction with mechanism, Cannizzaro reaction with mechanism, manufacture of ethanol by fermentation process. Okay, you will be able to know all the topics details. Thank you.